Hi, everybody. Welcome to our session at the Chicago Roboto, where we will be talking about modularizing your Android app the right way. My name is Enrique Lopez Manes, and I will be talking with my colleague, Phat and
Just very shortly about us. My name is Enrique. I'm a member of the Google Developer Expert Crew, and among other things, I'm the author of a few books, like Android High Performance. I've been working 12 years with Android and backend, more specifically Java and Kotlin.
Hello everybody, my name is Phat. I have been working in Android development for 5 years. I'm also the occasional speaker at the Kotlin and Android communities in Vietnam. I'm so excited to be here today.
Now, what's the motivation of modularization on our app? Let me bring a couple of definitions here. In modular programming, modularity refers to the compartmentalization and interrelation of the parts of a software package. Now, another definition would be, in software design, modularity refers to a logical partitioning of the software design that allows complex software to be manageable for the purpose of implementation and maintenance. The logic of partitioning may be based on related functions, implementation considerations, data links, or other criteria. This is a definition from the Wikipedia, which some of you may argue is a little bit too general. Since this is the Chicago Roboto and you want to see a little bit of Android content, let's gonna start talking a little bit more about the particular Android modularization. So, if you are an Android developer, chances are that you have seen this screen with way more than 4 minutes and 29 seconds until your app was built. Also, the day you die, you will probably see this in front of your eyes, since it's a screen that we see several times in our daily lives. So, what's the motivation to modularize while we're developing our Android app? One of them would be to speed up builds. To keep it simple, Gradle does two things to speed up builds. The cache work it did before, it caches the work it did before, so it doesn't have to do it again, and it tries to parallelize as much work as possible. Both of these strategies are not going to be effective for a single module app, since every code changes and makes it impossible to reduce the already generated or cache compiled code artifact, and therefore all the code has to be recompiled again sequentially. If we're working with multiple modules, Gradle can build several modules in parallel and avoid building modules that have no code change if the artifact has already been generated. This will speed up our incremental builds and even will clean our builds when we're using the Gradle build cache. Another motivation would be to have the on-demand deployment. You might or might have not used the on-demand delivery or Google Play Instant, but they benefit a lot from modularization. While you could argue that app size is not a major concern in most Western countries, the same cannot be said for all the parts of the world. And even if you are in a Western country, you might have areas where the internet availability is not that good, or maybe at the top of a mountain where the connection is slow. No matter where your users are, saving bandwidth and on device storage is always a nice thing to do. So on recent years, Android has added support for these two features. Instant apps allow users to run apps without installing them, and on-demand delivery allows to ship a smaller app with fewer features and downloading features on the fly when the user starts accessing those. Modularizing your app is the very first step if you want to support this. Even if you are not considering these use cases today, it will be a big win if your architecture is already being prepared for instant Google Play Instant and on-demand delivery, and you will benefit from any other of the points that we're mentioning. Simplify development. Well, you know what spaghetti code is, right? Code that gets too entangled and hard to modify and pretty much breakable. So modularization will help you to get rid partially or to avoid the spaghetti code. In a modularized world, you could still have a spaghetti code within a model, but at least this is going to be smaller, more digestible, and more manageable. And it will you will have a contract between modules, which is just don't decouple everything, but avoids that one changes causes side effects somewhere else. And it also forces you to group code in small parts. That makes the code easier to read, understand, and consequently, maintenance will also become much easier. It's always easier to build many small things than to build a very big thing. Now, reusability. Even if your business has no plans to launch several apps in the near future, you can still prepare for this and it will make sense. Maybe your business start becoming very successful and you want to launch a second app that reduces part of the initial one. Or maybe one day you would like to involve third-party developers in the platform and provide them access through an SDK. Or we would like to expose the app flow to third-party developers. Or maybe we would even like to take some part of our app and release it as an open source library or open source SDK to give back to the community that contributes, that we have taken always so much from. Striving to make modules reusable across apps is going to be great. And even if you never end up actually doing it. Refactoring. Well, monolithic apps are hard to change or improve. Changes are affecting all the other sections of the code, and that's mainly when we're cleaning up code in one place, this can have unforeseen effects in many other places. Another reason why monoliths are hard to refactor is because there is no easy way to gradually roll out improvements. So ideally, we want to refactor or rebuild functionality behind a Docker feature so we can verify that everything is working before actually deploying it. So this is about risk reduction, and having a properly modularized app will help us to reduce this risk. Experimenting. Sometimes we want to introduce new features into our app, even new languages. For instance, we would like maybe to include Compose in our app. Back in the past, we would have liked to use Kotlin instead of Java, or whatever framework that will be coming in the future. If we have a model that it's used for those experiments, it will become much easier. We can evaluate if this technology is for us. We can decide whether we want to include it or not. Now, using libraries. Libraries are going to provide us code that will be reused across some or most of our features. So those features in general, they will be generally Android libraries that they will never depend on the features or on the app. They're independent, and they may have dependencies on other libraries. Consequently, those libraries can be things such as UI components, networking libraries, data storage, extended functionality, etc. With a modularized code base, this is much easier to achieve since we essentially are already creating this concept of libraries. By the way, this is the library of Dujianjian in China, which is not a render image, and if you haven't been there, maybe you can start planning for your post-pandemic trip. And of course, Kotlin multi-platform. If you're an Android developer, chances are that you have seen Kotlin multi-platform before. And Kotlin multi-platform almost forces us into modularize our code. Essentially, we're going to have different modules. We will have our common module, then we will have our JVM, even JavaScript, or any sort of native module. If we want to compile into, let's say, a Win32 architecture or Mac, or typically for mobile developers iOS, we will have this native module, and then when we are generating our artifacts, this will generate for the case of iOS developers and a framework. So having a modularized app is a huge thing already for KMP. Now let's see how this translates into Android. This is our hello world. That's when we start our app on Android Studio, and we have an initial app folder where we start introducing all our code. Now, First evolution of this would be this, what you see here on the screen now. This contains a data, domain, and presentation layer or presentation models. This follows the code clean approach, and this already helps us to um, have our code better organized. Each of those models is independent, and well, they obviously have communication with each other, but this would be a first approach. Now, we can keep further evolving this, and you'll see this, by the way, comes from this repository that you see here, and this starts including more things. We can see here that we have a common module, core, experimental, which we have mentioned before, and might include some experimental technologies that we need to use, functional programming, if, for instance, we want to include anything using arrow, etc. Now, we have feature modularization that more or less works like you see here. We would have our app, and then our app would rely on several features. We could have features such as login, payment, registration, etc. Then if we go deeper into the level of modularization, we see that those features might have dependencies on some other modules or SDKs or libraries. So in this case, we might have something called network or analytics or UI. And we see that, for example, feature one, let's say our login might depend on network and analytics, but for example, feature let's say two, payment depends just on the network.
Okay, modularizing, what else? So thousands of approaches and tools are created to build up the multi-module applications. So remember the motivation, we have many of the problem already mentioned by Enrique. So you can consider the business strategy, the distribution model, you want to set it up with the Play Store or not, and the app scalabilities, you want to build a big app or just a medium or just a showcase, then you can decide which approach works best for you. Eventually, there are two common approaches that now being used by many applications, the top-down and the bottom-up. Talking about top-down, this approach is very straightforward. You will have the complex application to be broken down into smaller pieces. We call that modules, and those modules are self-contained and lower level. They will be using to integrate to the higher level modules later. And at the same time, you have to be brave to use this one because it's quite aggressive, and because it can introduce a cascade effect. By any change of lower level, it can break the functionality of the higher level modules or even the whole application. So be careful with that. So we have the diagram here for more details of the approach. Similar to the divide and conquer, on the complex problem, in this case, the app will be broken down into modules, and the module will be broken down into submodules, and the submodule will be broken down further and further until the submodules now have the clear responsibilities and simple enough to program. So with this approach, you will see the app is the highest level here. It's broken down into features, and the features share some common sort of functionalities that we call them library. In this case, we have some communication core and network to be using across the app. One thing to note here is that with at the features level, a features module should not depend on the other features. Otherwise, we'll call the circular dependencies. In general, what I personally like in this approach is to give you the advantage of development efficiencies when you and your team can work in parallelly at different features at the same time. So which is cool. Talking about bottom-up approach, this is mainly to build the dynamic features with on-demand delivery. So you can enable that option when deliver the app with Play Store. One significant difference comparing to the top-down is that the dependency direction is now reversed. So instead to have the app at the highest level, now apps will become base modules that centralize the configuration and dependencies like the version code, version name, etc. At the same time, in terms of change, it will cause less impact comparing to the top-down. Because of the dynamic features now built on top of apps, and it knows app very well, but the app doesn't know about dynamic features. So let's take a look at the diagram here. In another word, dynamic features now depend on the app modules, and also at the same time, you can fully control which features that you want to deliver to users by enabling on-demand delivery. One example for that, so if your app has a certain training activities like the interactive guide of how to use the app for the first install, for the first open the app, you can include that features by install, at the time app install by default. However, to reduce the install size of the app now can request to delete the features after the user has completed the training with that, which is really awesome. You can reduce the size of the APK file. Moving to the next line, modularizing step by step. So in this slide, we will try to practice to migrate from the business model into the multi-module applications. So this is the business models of the typical logistic company when the business are broken into three major categories: first mile, middle mile, and last mile. In first mile, driver will go to the seller house to pick up the parcel and then transport them to the middle mile. At this point, those parcels will be processed, and they will be using different vehicle types, including truck, airplane, or even bike, to transport them to last mile. In the final stop, the parcel will be delivered to the users. So we have a very clear expectation and responsibilities for each category, which will be really helpful for us to build up the multi-module application. Note that in this case, we are using the top-down approach when we have the applications modules is a higher level. It will be broken down into features modules, first mile, middle mile, and last mile. They will have their own responsibilities and their own life cycle, along with the view model, views, data, local database, or even server. They will use share and common functionality that will be grouped with at the library modules. For example, we have the share UI, which contains the common view that can be using inside the app or across the features modules. We also have an analytic for the tracking purpose. We have the APIs for the network call, and we have other library that can be useful and can be used inside the app. Here's the step-by-step that we personally think that could be really helpful for you to take on whenever you want to create a new features module. First, you need to review the scope of the features and also for the code base to decide if you want to extend off from the current code base or you need to create new features modules. Then draw out the expected dependency graph to understand the relation between the existing features modules. Later on, we can extract all the expected use case inside that features modules. The next step is that we can create additional functionality inside the library modules, base, core, utils, etc. Then we need to setting up for the navigation. So from other features module, you can open that screen accordingly. Later on, we need to extract the features module to the higher level so the app can use that, can import that and use that at the app level. So there are certain other problems we are facing during the time we are working with modularization. The first one is dynamic features. So by using the top-down approach, everything will be installed at once, which means you have features 1, feature 2 here, when the user download the app from the Google Play Store, everything will be installed, which make the size of the APK file increase significantly. But what we realize we don't have to do so, because one user, they are responsible for one applications only. So probably we can make it a little bit better if we can identify which is the application that it will be working for them, first mile, last mile, or live home. But we have the problem is that instead of the app depending on the features modules, right now we need to have some dynamic features that depend on the app. So as you can see, the reverse dependency direction here is quite complex and it's not easy to achieve. We need to reverse like everything. So previously we have the base configuration to be putting inside of features 1 or feature 2. Now there's many of them we need to put inside the app, like the version name, version code, etc. Many things. So it takes a lot of effort to achieve for this one. The second is the circular dependencies, when the features depend on other features. So some of the dependency injection library like Docker or Hill, they will complain if you resolve the circular dependency of those modules indirectly or directly, right? So the solution for this is we were trying to expose the similar function are being used in feature 1 and feature 2. We expose them into the separate modules, and by doing so, we can have both module to be calling to that function. And it can be accessible across the app level. Also, one raised issue here with the navigations. Unlike the monolithic applications, where we can just calling start activities or replace fragment, and then we can open the screen accordingly. With the modularizing the app, there are several ways that you can have you to navigate to different screens inside the app. You have to review if that one is within the modules. Then you can use the explicit intent on the navigation command like normal. You can start the activities or replace the fragment without any problem. But with the external modules, we need to use the implicit intent or the deep link in this case. So to make sure that the deep link is not conflict with others, make sure you define a universal scheme for that, right? We also define the prefix for the features module for any deep link and navigations when we create a new module for that. And also we can create an interface that across the features modules and the implementation and the app modules. So we can connect at any time, any place in the application, as long as you know the identity and the identification of that screen.
Another topic is resource conflicts. When the app grows, there are more and more resources that are being introduced, and especially when it comes to things like localization, things can get a little bit messy. So make sure you have a team agreement on how the resources should be named and located. Otherwise, it's probably going to mess up when the app continues to expand. So try to keep it as well centralized in a single module and be strong on this agreement. So this is mostly a problem about communication. Another issue are version conflicts, things like a Gradle versioning, etc. We want to centralize generally common dependencies and configurations. We could create a historical version file that can keep track of the snapshot version of a release. And we would like to have a central Gradle file that handles things such as min SDK, max SDK, etc. So you'll ideally end up with something like this. So this file will centralize the version that you're using of Room, the Android configuration you have, and it will apply model-wise. Still, you can have some exceptions. There are things such as forcing the resolution of a library on Gradle, but the more centralized and common this is for all the modules, is probably going to be better. Dependency injection. Depending on the library you use, some of them might differ, but the general concept is that you want to resolve the graph for each particular model on each particular model. If following previous examples, we have a model such as login or payment, and this model will have some dependencies that wants to resolve with, let's say, hilt or dagger. This should be done on this login or payment. Now, we're slowly approaching the end. There are a few resources that we would like to propose you. Jero and Mols has been writing intensively about modularization, and you can see some of his articles here. Then the instant apps from Google, they have also very nice and comprehensive documentation that you can read here, and the on-demand delivery. Last but not least, Andrei Beryukov has been writing a nice series of articles on how to make modularization of apps in 2021, proposing a few architectures. He has some open source code that you can check. We think you should check it out if you have more interest in learning about how to do proper modularization on Android. Last but not least, thank you everyone for being here and virtual attending. I hope in a post-pandemic future we can see you in person in Chicago. And if you have now any question and we have the answer to that question, we would be very happy to help you. Again, thank you so much for attending and have a fantastic day.